Okay, I have another quadratic for us to graph. We have h of x equals negative 2x squared minus 12x minus 16. So that's in standard form. If we want to find the vertex, we know two ways to do it. We'll go through both methods. First, let's talk about completing the square. Remember, if we're going to complete the square, the coefficient on the x squared has to be 1. And so this negative 2 is in the way, and we need to move it. We need to do something with it. So what we're going to do is we're going to group the first two terms together. Those are the terms that we're trying to complete the square on, and we're going to factor a negative 2 out of those two terms. The negative 16 at the end, we don't really care about, so we'll leave it alone. So let's go ahead and rewrite h of x as negative 2 parentheses x squared plus 6x close parentheses minus 16. So we factored the negative 2 out. We made the coefficient on x squared 1. And so now we need to look at the coefficient on x, which is 6. And we just need to do our little calculation. We're going to take half of that coefficient. Half of 6 is 3. And then when we square 3, we get 9. So this tells us that we should add 9 to complete the square on x squared plus 6x. So let's go ahead and fill that in. Now, notice if we add 9, then we should also subtract 9, shouldn't we? Well, yes, that's true, but we haven't really added 9. We added 9 inside these parentheses. This 9 is getting multiplied by negative 2. So instead of thinking of it as adding 9, let's think of it as subtracting 18. 9 times negative 2 makes negative 18. And so then in order to balance that out, we need a plus 18 at the end of the equation. That's a little tricky there. So we really have to be mindful that the 9 is inside the parentheses, and the negative 2 out in front is being multiplied by that 9. Okay, we ought to be able to clean this up and get the vertex form now. Negative 2 times x squared plus 6x plus 9 is going to factor as x plus 3 quantity squared. And then negative 16 plus 18 is plus 2. So there is the vertex form, and then we can read the vertex right off of it. We can look at this x coordinate. The plus 3 represents the x coordinate, except we have to change the sign, so minus 3. And then the plus 2 represents the y coordinate, and remember on that one we don't change the sign, so we just have negative 3 comma 2, and we can box that up. The algebra is a little tricky in this first method, so that's something that you are really going to have to practice with the homework. The second method I think is a little bit easier. We can just plug into the formula negative b over 2a. So let's see how that works. The b value is negative 12, so we have negative 12 divided by 2 times the value of a, that's the coefficient on x squared, that's negative 2. 2 times negative 2, so you have 12 divided by negative 4, which is negative 3, just like we expected. And then the y coordinate of the vertex requires that we plug in that negative 3 into the function. So we have negative 2 times negative 3 squared minus 12 times negative 3 minus 16. And then let's be careful here. There's a little bit of arithmetic. Negative 3 squared is 9 times negative 2 is negative 18. Plus 36 minus 16. When we put all that together, what is that? That's 18 minus 16. That's 2. We still have the same answer. We still have negative 3 for x and 2 for y. Fantastic. Since we have the vertex, we can go ahead and find the intercepts. To find the y-intercept, we'll plug into x. We'll replace x with 0. We'll have h of 0 is negative 2 times 0 squared minus 12 times 0 minus 16. We can see that's just negative 16. So 0, negative 16. And then if we want the y-intercepts, excuse me, and then if we want the x-intercept, we'll take the function and set it equal to 0. So we have negative 2x squared minus 12x minus 16 equals 0. And probably the quickest way to handle this would be to divide off negative 2 on each side, and that'll leave us with x squared plus 6x plus 8 equals 0. And then we can factor that. We can get x plus 4 times x plus 2 equals 0. So x plus 4 equals 0, or x plus 2 equals 0. If x plus 4 equals 0, then x equals negative 4. And if x plus 2 equals 0, then x equals negative 2. And we can write those as ordered pairs, negative 4, 0, negative 2, 0, and box it up. Okay, so we're ready for the graph. Let's see here. Let's not forget what we're graphing. The problem was h of x is equal to negative 2x squared minus 12x minus 16. So let's write that right up above the graph. And then let's go ahead and figure out how we're going to plot all these points on the graph. The y-intercept stands out because it's all the way down at negative 16. So actually, if I count by 2's on the y-axis, 2, 4, 6, 8, 10, 12, 14, yeah, 16 just fits. So negative 16 will be way down at the bottom, and I'll go ahead and plot that point. And then in the x direction, we don't need to count by 2's. We could just count by 1's. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. Label the origin. Okay, so we need a vertex at negative 3, 2. And we need x-intercepts at -4, 0 and -2, 0. Let's go ahead and draw that axis of symmetry. Did you notice that already that the graph was going to open down? How do you know? When we look at the leading term of the quadratic, the coefficient is negative, and so this tells us that the graph will open down. And of course that's what we see with the points on the graph. Let's get one more point on the graph. Let's take the y-intercept at -16 and reflect it over the axis of symmetry. That should get us over here. What is it? 1, 2, 3. So 1, 2, 3. So that would be -6, 16. And then we can connect these points up with a smooth curve. And there's our graph.